Hi, I'm Dave. I'm a geologist, and I wanted to talk to you about a really interesting time in Earth history, and that's the time when the dinosaurs roamed the Earth. Now, in previous exercises, you have seen you've collected, hopefully had a chance to look at some fossils from an earlier time in Earth history here in the Nashville area. You've seen some echinoderms, some bryozoans, some brachiopods, various types of corals. These are all very cool animals that lived basically on the seafloor. So what we know then from finding those fossils all around us here in the Nashville area is that what was Nashville, what is now well above sea level and in a sort of a temperate climate at that point, was in a much more tropical, much warmer climate, and these animals lived on the seafloor, so they lived under the ocean. So the oceans covered what where we are now. So that was sort of an earlier time in Earth history, just to think about the timeline that you've seen earlier in this series of videos. That corresponds to the yellow stripes on the timeline. So now we're going to zoom forward in Earth history and look at a younger time corresponding to the blue stripes on that timeline. Now I'm going to show you a paleogeographic map of what North America looked like at that point in time. As you can see, it looks sort of similar, but actually there's a lot of differences between what North America looked like then and what it looks like now. If you look in, zoom up on Tennessee, you can see that much of West Tennessee was actually under the ocean. So it was underwater. In Middle and East Tennessee, it seems like this was above the ocean, so this was land, the way we see the surface now. But probably, maybe rolling hills, maybe potentially going up into higher elevations as you move east. At any rate, it was well above land. Now I wanted to share with you an experience last summer. I actually participated in a dinosaur dig in eastern Montana, and I'll just kind of try to zoom in up on this map. Eastern Montana was right about here, and as you can see at that point, eastern Montana actually is sort of on the arm of an ocean, if you will, this western interior seaway that transgressed all the way across much of the western U.S. So it was kind of in a very coastal, very marshy sort of area that we were looking. And I just wanted to share with you very briefly what we found when we were looking at that area. So we found a lot of this. I don't know if you can see these, but hopefully you can. These are trees, but they're petrified trees. So it's petrified wood. So we found a lot of these sorts of things as we were looking through that area in eastern Montana. So not only did you have plant remains like this, abundant plant remains, we also had a lot of animals. And because this area in eastern Montana, like in Tennessee, was above the ocean, these were animals that roamed about the land surface. And I found this. And I wanted to share this with you, show it to you now. If you come to the Colossal Fossil Day on May the 21st, I'll actually be here with this fossil, so you can hold it, you can touch it yourself. But this is a real fossil. This is a real bone, and you can see it's a very large, dense bone. But this is actually from a T-Rex, from a large carnivore that existed during that time. This is probably, as best I can tell, probably the upper part of his knee. You can see where the upper bone articulated into this part of the bone. But at any rate, at that point in eastern Montana, we had big carnivores, big animals like this T-Rex running around. So the question then becomes, if we have large dinosaurs like T-Rex running around in eastern Montana, as you can see from this map, at this point in Earth history, there was a complete land bridge. It was completely accessible to these dinosaurs to move from that area into Tennessee. There's really no barrier, no land barrier that existed between them. Yet we really very rarely find, or hardly ever find, dinosaur bones in Tennessee. And when we do, they tend to be in sort of broken up bits in West Tennessee. So the question is, what happened? Why don't we find dinosaur bones in Middle Tennessee, in the Nashville area? Was it a question of they weren't here at all? Was there some barrier we don't know about that prevented them from coming? Or were they not here at all? So what we'd like to do today as part of our exercise is to do a little experiment. We're scientists, right? So we move science forward by experimentation. So in your classroom, you should have received 3 kits, and here's one here that contain various components. And I'm going to set this up for you right now, and then we'll run the experiment. I'll actually start it, and I'll let you run it in the classroom, and then we'll come back and talk a little bit about what it means, what it suggests to us. How do we answer that question that we posed of what happened to the dinosaurs? Why don't we see dinosaur bones here? And we'll suggest a possible answer. So let's set up our experiment. Let's set up a model that tries to actually emulate the topography of Tennessee at that time. So you have a couple of trays, a green tray and an aluminum tray, and underneath it you have a tarp. Now I know the tarp will be necessary in order to protect the tables and protect the areas, because we're going to be using water in this experiment. So we'll just spread the tarp out. Set up the aluminum tray, and then we'll try to set in the green tray. And you notice in the green tray you have 2 bags of sand, and one of the bags we're going to put at the bottom of the tray. So we'll spread that out. And then the other bag of sand we'll put in at the top part of the tray. So what are we trying to show with this experiment? We're trying to make a model of what the terrain looked like in Tennessee at that point. We said in middle and east Tennessee it was kind of probably rolling hills for the most part that were moving up gently to the east, but west Tennessee was under the ocean. So that's what we're trying to sort of emulate or copy, is that idea of terrain. So we have on one side of our model, the dipping in, we have the basin. This is meant to be representing the ocean, and then above that, on the other side, on the right-hand side, we have this terrain that existed in Tennessee at the point. So this is the land surface. So somewhere in here would be the ocean surface. Now, if we had dinosaurs that were actually roaming around in this area at the time of the dinosaurs, during the age of the dinosaurs, if they lived here, they would have lived and hunted and ate each other and died. And so once they died, their soft tissue would decompose and leave only the hard parts. And the hard parts are typically what we see preserved. These are the bones, the skeletal material that tends to be best preserved during the fossilization process. The soft tissue is hardly ever preserved. So in our model, we're going to try to emulate that. We're going to try to copy that. And what we've got here are a number of small bones. These are actually bones from very small mammals. But what we're going to say is, let's sort of pretend, or we're going to model like these are dinosaur bones. So we'll put some on our topography, on our terrain, to try to imitate at this scale what dinosaur bones would look like. So what we're going to say is, this is a model that simulates the topography at that point in time. And then what happens as we move time forward, as we go through geologic time? What's going to happen to that? Well, obviously it's going to rain a lot. And that's where the fun part comes in. Take your squirt bottle here, fill it up with water, and then very gently we're going to try to make it rain on this and just see what happens to these bones through the years as the rainfall continues. Now we'll move over to the next step. This is the model that's set up. It's already set up. We've filled our water bottle with water. And now what we're going to do is emulate rainfall through time. And we'll just see what happens. So this is Tennessee for the most part, middle and east Tennessee. This is the oceans that we're covering west Tennessee. So we'll just make it rain and just see what happens. Now I'm going to stop my experiment at this point, but I'd like to invite you in the classroom to make it rain yourself there.